So in the last class, we started looking upon to the properties of the aldehydes and the ketones. Physical properties we have seen. Chemical properties, I said we have categorized them into the different types. We have started with the first type of the chemical reactions, that was your nucleophilic reactions. Some of the nucleophilic reactions we have seen in the last class. Now the remaining nucleophilic reactions we will be covering in this particular class now. Okay, so we have seen in the last class the reactions that was with your HCN molecule. We have seen it with the Grignard reagent. We have covered with the hydrogen sulfide that was used for the purification of your aldehydes, and we have seen the reaction with your alcohol species. Now this is gonna be your fifth nucleophilic reaction, which is with your ammonia species. So reaction is with the fifth nucleophilic reaction. Basically we are gonna see that is your reaction with the ammonia. Reaction with the ammonia. So here if I have this carbonyl species, suppose this is my R, C double bond O and the R group. So this is the ketone species we have taken, and if you treat it with the ammonia, so in ammonia you can write it in this particular form. This is NH, and here this side you write it with the H2. So this is basically our ammonia, that is your NH3 species only. We have just presented in this particular form to understand this reaction. Whenever you are having the ammonia or the ammonia derivative species and you treat it with the carbonyl species, now what you have to do is just remove the water from here. Oxygen from the carbonyl species and the hydrogen group, that is H2 molecule, from your ammonia species or the ammonia derivatives. So you will be getting here is R with the carbon, here the carbon, double bond N and the H species. This is called as the imine species. So if you are treating it with the carbonyl species are being treated with the ammonia, we get is the imine species. Okay, so let us look upon to the mechanism also. Right, if direct product you can write it in this manner, there is no problem, but you should have a bit idea about the mechanism of it as well. Suppose this is my carbonyl species I am having, and in this we are treating it with the ammonia, and for this reaction generally the pH it is kept to be around 4 to 5. pH 4 to 5 basically means it is acidic in the nature. On the pH scale you have like this now. On the pH scale generally that is at 25 degrees centigrade I am talking. pH is from the 0 to 14. 7th 0 to 7, this pH is equal to the 7. This represents your neutral position, and this in the region that is 0 to 7, this lies in the acidic conditions, and the pH ranging from 7 to 14 it represents our basic conditions. We are taking is pH value as 4 to 5, that means acidic medium we are using over here. Okay, so that means pH is 4 to 5. So why is it 4 to 5? Because here you will be having the H positive over here. Now here the oxygen carrying the positive, this electron density, it will be abstracting this H positive. So due to that, what is gonna happen, here the OH, sorry, here you will be having double bond oxygen with the hydrogen, here the positive charge. So this is just increasing the electrophilicity of this particular carbon center, because initially you were having only the oxygen atom that was withdrawing the electron density. So here it was your partial positive charge, it was being partial negative charge, it was generated over here. Now since oxygen is carrying the positive charge, that means electronegative atom with the positive charge, highly unstable. So it will be attracting this electron density towards itself, creating more of the positive charge over this carbon side. Basically electrophilicity of this carbon center is being increased by the pH taking 4 to 5. Okay, so here electrophilicity of the carbon center, it increases with pH ranging from 4 to 5. Right. Now in the next step, the nucleophile that I am having is my ammonia. Right. Now ammonia, nitrogen contains the lone pair of electrons. It is gonna come for the attacking at this carbon side. This electron density is shifted, giving us the R with the carbon, here the OH, here the R group, and the attack of the NH3 positive has taken place. Nitrogen, it has donated its electron density, so positive charge is coming over the nitrogen atom, right? In the next step, this oxygen atom containing the lone pair of electrons will be abstracting this proton from the ammonia, because the positive charge over the nitrogen center, it can be neutralized. So we will be getting R with the carbon, here the N, H2 you will be having, and here you will be having the water. So here basically the intramolecular proton transfer has taken place. Intramolecular proton transfer. Okay, so this H2O is present. Now this oxygen atom will be having now the positive charge. So now what is going to happen? This nitrogen now contains the lone pair of electrons. This is providing it a push, and this water is going to leave from the medium, giving you the imine species. So we are getting is R with the carbon, here the R group, here the double bond N, and the H species. This is called as the imine. So you can see here the loss of the water has taken place, that we directly did in the first step. So this is the complete mechanism of this particular reaction. So whenever my carbonyl species are treated with the ammonia or the ammonia derivatives, further you will be seeing there also the water species you have to remove it, and this is the mechanism for that. Okay, suppose if you have this aldehyde species I am having, that means if aldehyde is treated with the ammonia, you get the species, it is called as the, because imine species you are getting. So the name is given as LD-imine. LD-imine. And just like the acetal and the hemiacetal we were getting, based upon the aldehydes it was treating with the alcohols, or the ketones it was treating with the alcohols. So we were calling them the hemiacetal or the acetal, or we were calling them the ketones or the hemiketal groups. Now if the ammonia is being treated, so imine it is formed. If aldehyde is treated, we get the LD-imine. Here if the ketone is treated with the ammonia, we are gonna get is the ketamine. It is called as ketamine. Ketamine. So these are the names given to it. Okay, based upon the carbonyl species which is being attacked by the nitrogen center. Okay, now next one, a specific reaction is there, that is when you have the formaldehyde and you treat it with the ammonia. If you have the formaldehyde, that is HC double bond O and the H, so this is your formaldehyde, and you treat it with the